Hi everyone, in this demo we present our tools that automatically detects for likely design faults in entire architectures in object-oriented programs. Entire architecture is a recommended industry practice as it promotes separations of various concerns into layers. One commonly used in entire architecture is the separations of classes into three stereotypes, namely boundary, control, and entity. Class stereotypes are not just symbols. They come with design rules governing their behaviors and responsibilities. There are two common rule variants: robustness rules and well-formed rules. Unfortunately, many software projects have little documentations. Many design documents, including those specifying stereotype labels of the classes in a program, are often missing. Such information is not obvious in the source code either due to poor variable or class naming, code changes, etc. Also, keeping design documents and stereotypes up to date manually could be time-consuming and error-prone. We have implemented our tool as an Eclipse plugin and have tested on a number of student projects and real software systems. The tool can infer class stereotypes and then detect violations of the design rules. Its workflow is shown in this diagram. It has two phases, namely training phase and violation detection phase. In the training phase, we build a statistical model using a machine learning technique that can discriminate the class stereotypes based on a set of class with given stereotypes. In the violation detection phase, given a class or a program containing more than one class with no stereotype labels, we predict the corresponding stereotype for each class based on the model. There are 5 different processes in the framework. First is the extraction of basic information and then feature constructions. These processes are used both in training and violation detection phases. During the training phase, we use a machine learning technique, namely support vector machine, to construct a statistical model. In the violation detection phase, this model is used to assign likely stereotypes label to classes in the test program. The stereotypes are then checked against the robustness or well-formedness design rules so that violations that signify likely design defects can be detected. Now we demonstrate how our tool works as an Eclipse plugin. The plugin consists of an additional button in the Eclipse toolbar. In this button, 3 options are presented to the users: training and violation detections, using either robustness or well-formedness rules. Now, we would like to train a model. Once a user starts the training phase, a dialog box would appear to ask for the jar files of the projects along with files containing stereotypes label for the various classes in the projects. User may add in more than one jar files and its associated stereotype labels. When we are done, we could click the Train Model button to continue. Once our system is trained, it could be used to detect for likely violations of the design rules, either robustness or well-formedness. When we want to check for violations, click the button again and choose one of the violation detection options. In this demo, we choose Check Robustness. Internally, our system will compute likely stereotypes of the individual classes based on the internal train model for the current open project in Eclipse, which is G4T02 project. This step is transparent to the users. The stereotypes of the classes in turn will be used to detect violations in the current open project that would then be reported to the users in additional tab at the bottom of the Eclipse IDE. User could then click any of the reported violations and our system can bring the user to the code containing the likely design violations. This is an example of violations of design rules. The trap Smith menu with a boundary stereotype calls trap item with an entity stereotype. This is not permitted by robustness rules. In addition to the violations, the stereotype labels that our tool infers for the classes in these projects are displayed in the left panel. This will allow users to get more information about the stereotypes for each class. As a summary, we have demonstrated a tool that can automatically learn the stereotype labels for class in object-oriented programs. It can also detect likely design flaws by finding violations of well-known design rules. Our tool has been implemented as an Eclipse plugin. Preliminary experiment results on several small and medium-scale projects are promising. Thank you for your attention.